I'm here. Hi there. My name's Matt Chubb, and I'm here today to try and answer the question, how much QA is enough? Or where do you draw the line when you're venturing down the QA rabbit hole? But first, we should answer the question, well, why do we even want to QA in the first place? Like, why test our code? Well, I want to make sure my code works. I want to be absolutely 100% certain that my code is never going to fail. Well, I got some bad news for you on that one. That's impossible. It is literally impossible to make sure your code will always work under every scenario. What we can do, however, is we can at least lower the risk that your code is going to break. So actually, the reason we QA is to lower the risk of our code breaking. Now, some of you might be familiar with the test pyramid. So the idea is that we have several different kinds of tests that we can point at our application. Different tech stacks will have different blends of these. They might not have any of these, and some of them might be called different names. So at the bottom, you've got unit tests. So can I put input X into this method and get output Y back? Everybody should have these. If you don't, then why? They're quick to write. They're very quick and easy to run. They form the foundation of most people's test suites. Then we have integration tests, sometimes called by various different names. I've heard these called module tests. I've heard these called smoke tests. Essentially, it's can I put X into a series of methods joined together and get Y back? So does your program tie together as a whole? Going a layer up, we've got API tests. Can I spin up a backend service, make X request to it, and get Y response back? Going up even further, we've got UI tests. This assumes you have an actual UI. Can I spin everything up, press this button on the web page, and see Y happen? And then right at the top, there's end-to-end tests. This is, can I spin absolutely everything up, the entire tech stack, all dependencies, and follow a full user journey from beginning to end? These are incredibly difficult to do. These are very difficult to implement. I've seen them implemented successfully, I think all of 2-3 times in my entire career. Even getting a connected up QA environment to do this is a feat in itself. The pattern here is that as we go up the list, you have higher coverage. An end-to-end test isn't just going to hit the workflows and that design. You're also going to hit the UI. You're going to hit the APIs beneath it and the integration layer beneath it and right down to the individual units. However, as I said, end-to-end tests, very high cost, both in time, money, and compute to run. Unit tests, they're going to have much lower coverage, but they're much lower cost, both to build and to run. You can run unit tests on your own machine. End-to-end tests, chances are you're going to need a QA environment to run. And so finally, putting it all together, well, that looks like a pyramid. So the idea is your unit tests, these are your foundations. This is what you're building everything on. You should have loads of these. Then you have, if you have time, a few more integration tests. You'll still have quite a few, but not as many as you have unit tests. As you go up, API tests, all the way to end-to-end tests. Realistically, you probably only need a few of these because it's actually going to cover quite a lot. And your test coverage that you've got further down the pyramid is already going to be providing quite a bit. But wait, there's more. There's actually loads of other different forms of QA. These are all they're all just different tools in the tool belt. So in no particular order, we've got peer review, we've got static code analysis, load testing, performance benchmarks, A/B testing, stage rollouts, mathematical proof that your algorithm works. You can get some users in to have a look at it. You can do security auditing in your code, chaos engineering, cross-platform or cross-browser testing, you can manually fire it up and have a poke around. Packed testing to check your APIs integrate together. You can get your product manager to go and have a look at it. And many more. This is just what I could come up with in a couple of minutes. There are loads of these. The point is, they're all just tools in our tool belt. We can use them as we see fit. And we shouldn't just rely on one type. That's what I'm trying to say. You can spend all your time writing unit tests, but after a while, you're going to get into diminishing returns, as I've tried to illustrate on this absolutely amazing quality drawing here. So we can spend our time writing unit tests, but past a while, we will get diminishing returns, and we'd be better off adding a different form of testing on there. So maybe we're building some integration testing, or maybe it's time to write some UI tests. So to get the best test coverage, we need a combination. And the benefits all stack somewhat. So in one example, we've got very good unit test coverage. And if we see in this grey space being all the possible tests, things that we could possibly be testing, the unit test is that giant red circle. That's covered quite a lot, but it's never going to cover everything. So we then also have got, a handful of API tests. Maybe one developer experimented with them for a while, then left the company, and they're still there running. They provide a bill of value, but nobody's really expanded. But then maybe you've got a dedicated QA team. They've written a whole load of end-to-end tests, and that's actually covering quite a lot. And then maybe you also had the product manager had a look and did the exact same thing that the end-to-end tests did. So you're not actually getting that much extra benefit there, but it's still worth doing. And this might take you 6 months to build, this example. In another example, you might not have very good unit test coverage. On the other hand, you have very, very good packed testing across your entire API stack. You've also done a load of volume and performance tests and chaos engineering, and this will have taken you a little bit longer to build. But actually, for your application, this might make much more sense. And you might end up with the same actual amount of test coverage. But this just tells you what QA tries to achieve and a bit of how it works. I'm not really asking the question, how much QA is enough? Well, rather than asking how much QA is enough, we know how much QA we can point at our application. We should ask, what happens if my code breaks? So if there is a bug in my code, what is the worst possible scenario that can happen? It could be absolutely nothing because you're just hacking around with a new framework. You have no intention of putting this live. Sure. It could be something. So maybe an icon loads a millisecond slower. It's something, but there's no real impact to the business. It could be a small loss of revenue. Maybe a single customer in some very isolated case can't place an order. So you're losing money, but only a tiny bit. Maybe you have a small outage. Many customers can't place orders. Maybe all your customers' payment data gets leaked and you've got a major loss of reputation or revenue and you're getting sued and your company's going under. That's pretty serious. You may also have, say, a self-driving car. If there's a bug in your code, there's a risk of injury or death. Or say there's a bug in your AI, it goes rogue and attempts to destroy humanity. Well, a bug in your code could result in global thermonuclear war. It's all kind of on a different scale of impact. So if nothing happens, I'd say that's very low impact. Something, but no loss of revenue, and also no actual business impact. Also, the impact you can measure in pounds to, risk of injury or death, global thermonuclear war. I don't really have time to get into the philosophical argument of how you try and quantify that. Least to say, I'd say it's pretty high impact. So I ask again, how much QA is enough? Well, I have a formula. Say we do no QA. The expected cost of doing no QA is the financial impact times the risk of it happening. If you do QA, this reduces the risk. So in fact, it's impact times the risk of it happening after you've done some QA to reduce that risk, plus the cost of the actual QA, so expected cost. So for example, my feature is used once in a blue moon. I guess if it breaks, it might annoy a customer enough to drive them elsewhere. In this example, sure, we have a 10% chance in the next 5 years of this happening to a single customer, and we would lose £100 in order value. So let's also say our QA engineer's time costs £100 a day, just to make the math easier. So if we didn't do any QA at all on this, a 10% chance of it happening times 100, you expect this bug to cost you £10. That's actually not much. What if we spent a day or two to write a few UI tests for it? Well, that massively reduces the risk of this code breaking, but it's going to cost you a day's worth of time. So actually, the expected cost is just over £100. So it's actually still cheaper just to leave this untested. Or we could spend 5 minutes adding some unit tests. It's going to reduce the risk. Still a good amount, but not as much as the UI tests. But actually, that doesn't matter because it takes 5 minutes. And so your expected cost is then £2. Or at the other end of the scale, we want to spend an entire week overanalyzing our performance benchmarks. It's going to do a small amount to reduce the risk, but it's going to cost you way more time than it's even worth. Let's take another example. Say I'm writing the guidance system for the Apollo 11 rocket. If it goes wrong, the rocket's going to crash. The impact is a $288 billion rocket, worth even more in today's money, plus certain death, plus international headlines that your rocket had crashed. And the risk, actually, if you don't test it, I say there's a fairly high chance it's going to happen during the mission. So if we don't QA, it's going to cost us, well, the expected cost is $259 billion plus the cost that you can't quantify of international headlines and people dying. What if I spent a month writing 100% unit test coverage of everything? It's going to reduce the risk of things going wrong, but still not by enough. You're still risking a load of people's lives, international headlines, and hundreds of billions of dollars. So what if we do component tests, manual testing, mathematical proofs, peer review, thermal analysis, performance testing, end-to-end testing in the rocket, and every other possible kind of testing that NASA can come up with? That's going to reduce the risk a lot. You'll still have an expected cost of failure, but it's way less, and it's an acceptable risk. So this course doesn't tell the full story. Estimation is hardly ever accurate. You'll underestimate your risk. You can overestimate your risk. You can underestimate the impact, overestimate the impact. And the impact and risk of this service can change over time. We've all had that proof of concept code that we just chucked out there that we then turn around and realized 2 months later was being used in production. We also know that good tests speed up development. We should all be doing TDD. Good unit tests really do help. It speeds people up. So there's other reasons than reducing risk to write tests. As I showed briefly in the example earlier, not all tests provide useful coverage. There's no point doing security testing on an application that you're never going to put live or has no security concerns associated with it. You'd be better off increasing your unit tests. Not all test scenarios are obvious. There's always going to be that one obscure situation that you never anticipated. Also, testing is hard. Like spinning up new forms of testing takes time to learn. And there's also an option of lowering the impact of something failing. You can have a fail-safe, you can have manual overrides, you can have redundant systems, all kinds of things. So, wrapping it up, finally, how much QA is enough? I can't give you a definite answer. Honestly, it is up to you. But my suggestion is it's enough that you and your team are okay with the risk. That's what I'd say is enough QA.